In this animation, we will illustrate Hess's law. Hess's law is an application of the law of conservation of energy to chemical systems. This law states that the total enthalpy change associated with a chemical change is independent of the route by which that change takes place. This diagram shown here can be used to express Hess's law more simply, as delta H1, the enthalpy change 1, is equal to delta H2 plus delta H3. We are going now to examine the enthalpy changes associated with two routes that might be followed in the formation of ammonium chloride, NH4Cl. So our desired product is NH4Cl. This is the product that we want to obtain at the very end of the reaction. The first way of producing NH4Cl is starting with its elements, which are nitrogen, hydrogen, and chlorine. And they are in their standard states. What would the name of the enthalpy change delta H1 for this process be? So we are producing 1 mole of NH4Cl starting with its constituent elements in their standard states. Exactly, so delta H1 will be the enthalpy of formation of ammonium chloride. The alternative route might be to form ammonia, NH3, and hydrogen chloride separately before reacting them together to form ammonium chloride. So we will produce NH3 and HCl, which will react in another reaction to form NH4Cl. What enthalpy changes would make the total enthalpy change of this reaction, which is this one, delta H2? Exactly, it's the enthalpy of formation of ammonia and the enthalpy of formation of hydrogen chloride. Notice that the value of delta H1 is equal to the sum of delta H2 and delta H3, and this is Hess's law. Let's take another example. In this example, we have the oxidation of ammonia to nitrogen. So our final product will be nitrogen. So now we want to produce an energy cycle that will enable us to find the enthalpy change of this reaction. So we can start with the constituent elements and produce directly end-to-end H2O, or we can produce from the constituent elements ammonia, and then we will have the oxidation of ammonia to nitrogen. So if we add delta H2 and delta H3, we will obtain delta H of this reaction, and this is again an application of Hess's law. Let's take another example, which is the combustion of methane. So the combustion of methane should produce carbon dioxide and water as the final products. So these are the carbon dioxide and water. We can start with the starting materials of this product, which are carbon, hydrogen, and oxygen in their standard states, and produce directly carbon dioxide and water, or we can use these to produce methane, which will undergo then a combustion reaction to produce carbon dioxide and water. According to Hess's law, delta H1 will be equal to delta H2 plus delta H3. Let's check. So delta H2 plus delta H3 is equal to minus 74 plus minus 890. Of course, don't forget to consider the sign of the enthalpy change. So minus 74 plus minus 890 is equal to minus 964 kilojoules per mole. So this is Hess's law.